Classification of routing protocols. Routing protocols for ad hoc wireless networks can be classified into several types based on different criteria. A classification tree is shown in the next slide. The routing protocol of ad hoc wireless network can be broadly classified into four categories based on routing information update mechanism, use of temperamental information for routing, routing topology, utilization of specific resources. These are the classification of sensor network protocol. So they're basically classified into path establishment, network structure, protocol operation, initiator of communication, and further divided into protocol proactive, reactive, hybrid, flat, hierarchical, local based, path based, query based, negotiation based, QoS based, coherent and non-coherent based, source and destination. Let's see one after the other. Based on routing information update mechanism, ad hoc wireless network routing protocol can be classified into three major categories based on routing information update mechanism. They are proactive or table-driven routing protocols. Every node maintains the network topology information in the form of routing tables by periodically exchanging routing information. Routing information is generally flooded in the whole network. Whenever a node requires a path to a destination, it runs an appropriate path-finding algorithm on the topology information it maintains. Second is the reactive or on-demand routing protocol. They do not maintain the network topology information. They obtain the necessary path when it is required by using a connection establishment process. Hybrid routing protocol. Here, the combination of the best features of the above two categories are done. Nodes within the certain distance from the node concerned or within a particular geographical region are said to be within the routing region of the given node. For routing within this zone, a table-driven approach is used. For nodes that are located beyond this zone, an on-demand approach is used. Second, based on the use of temporal information for routing. The protocols that fall under this category can be further classified into two types. Routing protocol using past temporal information, that is, use information about the past status of the link or the status of links at time of routing to make routing decision. Routing protocol that use future temperamental information, use information about the expected future status of the wireless link to make approximate routing decisions. Apart from the lifetime of wireless link, the future status information also includes information regarding the lifetime of the node, prediction of location, and prediction of link availability. The third is based on routing topology. Ad hoc wireless network, due to their relatively smaller number of nodes, can make use of either a flat or a hierarchical topology for routing. Flat topology routing protocol. Make use of a flat address scheme similar to the one used in IEEE 802.3 LANs. It assumes the presence of a globally unique addressing mechanism for node in an ad hoc wireless network. Hierarchical topology routing protocol. It makes use of a logical hierarchy in the network and an associated addressing scheme. The hierarchy could be based on geographical information or it could be based on hop distance. Fourth, based on utilization of specific resources. Power-aware routing aims at minimizing the consumption of every important resource in an ad hoc wireless network. The battery power. The routing decisions are based on minimizing the power consumption either locally, logically or globally in the network. geographical information assisted routing. It also improves the performance of routing and reduces the control overhead by effectively utilizing the geographical information available. Table-driven protocol or proactive. These protocols are extension of the wired network routing protocol. They maintain the global topology information in the form of tables at every node. Tables are updated frequently in order to maintain consistent and accurate network state information. Some of the examples involved are Destination Sequenced Distance Vector Routing Protocol DSDV, the one which is very commonly used. Wireless Routing Protocol WRP, Source Tree Adaptive Routing Protocol STAR, Cluster Head Gateway Switching Routing Protocol CGSR. We are going to see in detail DSDV. Destination Sequenced Distance Vector Routing Protocol DSDV. Destination Sequenced Distance vector is a hop-by-hop vector routing protocol requiring each node to periodically broadcast routing update. Destination Sequence Distance Vector Protocol is a modified version of Bellman-4 algorithm and is based upon the concept of DVR, that is Distance Vector Routing. In DVR, each node broadcasts a table containing its distance from nodes which are directly connected, and based upon this, other nodes broadcast the updated routing. These nodes, which are unreachable directly, are labeled as infinite. But this updation of routing tables keeps on happening and an infinite loop is generated, which is commonly known as count to infinity problem. To overcome this problem of count to infinity by generating sequence number in the routing table every time the routing table is updated. The process of DSDV is the same as that of DVR, but an extra attribute of sequence number is added. Let's see the concept of DSDVR. DSDV protocol uses and maintains a single table only. For every node individually, there is a single table that has been maintained. The table contains the following attributes. Routing table, it contains the distance of a node from all the neighboring nodes along with the sequence number. Now sequence number means the time at which table is updated. So the DSDV table format is given and the attributes are node, destination, next hop, distance, sequence number. This table is updated on every step and assumes that each node broadcasts as well as receives correct information about all the nodes, including their distance and sequence number. The working of DSDV. In DSDV, nodes broadcast their routing table to immediate neighbors with a sequence number. Every time any broadcast occurs, the sequence number is also updated along with the distance of nodes. A sample of network of DSDV is given and the figure is considered having 3 nodes and the distance of 1 on each of the edges respectively. Below mentioned will be the steps which will let you know how DSDV works and routing tables are updated. So here separate tables are drawn for all the nodes X, Y, Z. As we said that we have 3 nodes and all 3 different tables are drawn along with the destination and sequence number. This is how DSDV works. Let's see the advantage and disadvantage of DSDV. The advantages are less delay involved in route setup process, mechanism of incremental update with sequence number tags makes the existing weird network protocols updatable to ad hoc wireless network. The updates are propagated throughout the network in order to maintain an up-to-date view of the network topology at all nodes. The updated due to broken links lead to a heavy control overhead during high mobility. Even a small network with high mobility or a large network with low mobility can completely choke the available bandwidth. suffers from excessive control overhead. In order to maintain information about a particular node, a node has to wait for a table update message initiated for the same destination node. On-demand routing protocols or reactive protocols. In table-driven protocols, each number maintains up-to-date routing information to all the nodes in the network, where in on-demand protocol, a node finds the route to a destination when it desires to send packets to the destination. Ad-Hoc on-demand distance vector routing protocol. This protocol is an example of reactive routing protocol which does not maintain routes but builds the route as per requirements. That means route is established only when it is required by a source node for transmitting data packet. AODV is used to overcome the drawbacks of dynamic source routing protocol and distance vector routing protocol. That is, dynamic source routing protocol is capable of maintaining information of the routes between the source and destination, which makes it slow. If the network is very large, containing a number of routes from source to destination, it is difficult for the data packets to header to hold whole information of the routes. In case of dynamic source routing, multiple routes are present for sending a packet from source to destination, but AODV overcomes this disadvantage too. In AODV, along with the route tables of every node, two counters including sequence number and broadcast ID are maintained. The destination IP is already known to which data is to be transferred from source. Thus, the destination sequence number helps to determine an updated path from source to destination. Along with these counters, route request and route response packet are used, in which route request is responsible for discovering the route from source to destination, and route response packet sends back the route information response to its sources. So here is the working of Ad-Hoc on-demand distance vector routing protocol is given. We see there is a source which is marked with red and a destination which has been marked with green. In Ad-Hoc on-demand distance vector routing, the source node and destination node IP address are already known. The goal is to identify, discover, and maintain the optimal route between source and destination node in order to send, receive data packet and informative. Each node comprises of a routing table along with below mentioned format of route request packet. Route request packet consists of destination IP, destination sequence number, source IP, source sequence number, and hop count. Consider a figure containing 5 nodes. It's given, that is X, Y, Z, T, D, present at unit distance from each other, where X being the source node and D being the destination node. The IP address of source node X and destination node D is already known. The steps are mentioned that will let you know how AODV works and concept of route request and route response is used. The first step, source node X will send route request, that is RREQ packet, to its neighbors Y and Z. Step 2, node Y and Z will check for route and will respond using route response packet back to source X. Here, in this case, Z is the last node but the destination. It will send route request packet to X stating route not found. But node Y will send route response packet stating route found, and it will further broadcast the route response to node T. Step 3. Now the field of net hop in the route request format will be updated. Node T will send back the route found message to node Y and will update the next hop field further. Step 4. The node T will broadcast and route request packet to node D, which is the destination, and next hop field is further updated. Then it will send route response packet to T, which is further be sent back to the source node X via node Y and node T, resulting in generation of an optimal path. So this is how the working of an AODV takes place. It fully deals with route request and route response packet. The advantages and disadvantages of AODV. Some of the advantages: dynamic networks can be handled easily, there is no loop generation. And the disadvantage includes a delayed protocol because of its route discovery process and high bandwidth requirement.